In this video, we'll be solving matrix equations using inverse matrices. A matrix equation is an equation in which a variable is used to represent a matrix. Matrix equations can be used to represent systems of equations. We will be using the matrix equation AX equals B, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. So we have a system of linear equations here and then the corresponding matrix equation. The first matrix, this is our matrix A, is the coefficient matrix. Basically, it's the left side of an augmented matrix. The next matrix, the X matrix, is our variable matrix. That's the one that's all full of variables, and it's equal to our constant matrix. So that last matrix is like the right side of an augmented matrix. We can solve matrix equations and ultimately systems of equations using inverse matrices. So this is how we're going to do that. If AX equals B has a unique solution, then X is equal to A inverse times B. To solve a linear system of equations, we're going to multiply A inverse times B to find our variable matrix X. So I just want to show you where this comes from. This is really what you need to remember, is that X is equal to A inverse times B, but let me show you where we get that. If I start with this matrix equation, A times X is equal to B, I am going to multiply both sides of this equation on the left by A inverse. This is a legal math move because I'm doing the same thing to both sides of the equation. Also, remember that matrix multiplication is not commutative, so if I'm multiplying on the far left side of the equation, A inverse, I need to multiply the far left side of the right side of the equation by A inverse as well. We learned in a previous video that the inverse matrix times the inverse of that matrix is always equal to the identity. So A times A inverse is equal to the identity, and that's still going to be times our matrix X equals A inverse times B. And then the identity matrix, when we multiply that by any other matrix, well, we just get that other matrix. This is where we get the equation X equals A inverse times B. So let's see this in action. We want to write each system as the matrix equation A times X equals B, and then we're going to solve the system by using the inverse matrix, which I've provided for you. So the first thing we want to do is write our matrix equation A times X equals B. A is our coefficient matrix, so we're just taking the coefficients 2, -3, 1, and 1. We'll then multiply that by our variable matrix X, and our two variables are X and Y, and you'll notice that we're writing that vertically. And then it's equal to our constant matrix, and our constants are 12 and 1. So this here is the matrix equation. Now we're going to use the inverse provided to solve this matrix equation. When solving this matrix equation, we know that our variable matrix X is going to be equal to A inverse times our constant matrix B. So X which is our variable matrix xy, is going to be equal to our inverse matrix times our constant matrix. And we're just doing regular matrix multiplication. We'll check our dimensions. We have a 2 by 2 times a 2 by 1. Our middles match, so we know that we can perform the multiplication, and then the outside numbers give us the dimensions of our product matrix. So our answer is going to be a 2 by 1. Hopefully that's not a surprise to you, because this is what it's going to be equal to, which is a 2 by 1 as well. And now we just have to do the multiplication. I'm going to put A and B here because that's what we've been doing. However, you're welcome to just use the variables x and y there, since technically that's what we are equal to. So element A is located first row, first column. So we'll be multiplying first row of our first matrix with the first column of our second matrix. Element A is going to be equal to 1/5 times 12 plus 3/5 times 1. That'll be 12/5 plus 3/5, 15/5, which is equal to 3. And then our element B, it's positioned second row, first column. So we'll be multiplying the second row of the first matrix with the first row of the second matrix. Element B is going to be negative 1/5 times 12 plus 2/5 times 1. That's negative 12/5 plus 2/5, negative 10/5, which is negative 2. What we found here is our variable matrix x, y. And since we are solving a system of equations, we always want to write our solution as an ordered pair. The solution to this system is the ordered pair 3, negative 2. Let's try another one. Let's do a 3 by 3 this time. We'll start by writing out our variable matrix. A times x equals b. So we're starting with our constant matrix. And then we'll multiply it by our variable matrix. This time we have 3 variables involved, so this variable matrix should also have 3 variables, x, y, and z. And then we're equal to the constant matrix, 2, 3, 3. We'll be using the inverse matrix provided to solve this. We know that our x matrix, our variable matrix, is equal to our inverse matrix times the constant matrix. We'll perform the matrix multiplication as we typically do. Note that we have a 3 by 3 multiplied by a 1 by 3. Our middles numbers match, and our outside numbers tell us that our result will be a 3 by 1. Again, we should be anticipating a 3 by 1 since it's supposed to be equal to our variable matrix there. Okay, element A is located first row, first column, so we'll be multiplying the first row of our first matrix with the first column of our second matrix. That's 2 times 2 minus 1 times 3 minus 1 times 3. 4 minus 3 minus 3 is a negative 2. Element B is located second row, first column, so we'll be multiplying the second row of the first matrix with the first column of the second matrix. B will be equal to 12 times 2 minus 7 times 3 minus 2 times 3. 24 minus 21 minus 6 gives us negative 3. And lastly, our element C is located third row, first column, so we'll be multiplying the third row of our first matrix by the first column of our second matrix. That'll be negative 5 times 2 plus 3 times 3 plus 1 times 3. It's negative 10 plus 9 plus 3 to give us a positive 2. Great. What we have is our variable matrix, but since we are solving a system of equations, of course we want to write our solution as an ordered triple, and our ordered triple will be negative 2, negative 3, and 2.